Let's take a look at another example. This one is quite similar to our previous one, but we're going to find out that there's something really quite different between the tree diagram that's produced here and the one that we'll get in this example. For this second experiment, a box contains 3 red and 3 blue balls, and 2 balls are selected as follows. You're going to withdraw a ball at random, record its color, and then withdraw a second ball, but do that without replacing the first. So that means we'll be looking at either red or blue, and we'll be looking at things like this. R2, B2 means red on the second draw, blue on the second draw. Had those been ones, then it would be red on the first and blue on the first. In how many ways can we select 2 reds? In how many ways can we select one of each color, etc.? The answer to that question is not really quite as easy as it might seem. So let's draw a tree diagram and see how that will help us answer this question. So the idea now is we have a starting point. Then we're going to draw out one ball at random, and the only thing in here are red and blue. So you'll get either a red or you'll get a blue. And then once again, you draw a second time and get a red or a blue. And instead of getting a red on the first, it might be that you get a blue on the first. And then you could get a red or you could get a blue. But notice these are on the second draw, so we call those R2B2, R2B2 here. So red on the first, red on the second, red on the first, blue on the second. Now, the question that we are asked is this: in how many ways can we select 2 reds? So we're not doing probabilities here directly, we're looking at counts. So let's think about this. Sometimes it kind of helps to draw a little bit of a picture. The notion is that we have 3 balls in here which are red, and we have 3 of them in here which are blue. Of course, I don't have the colors, but at least I can get some kind of a visual. Now, the idea is, what will happen if we draw at random, mix these up thoroughly, draw at random. There are 6 balls in here to start with, and 3 of those 6 are red. If I put the fraction in here, 3, 6, I would get the probability. If I just say 3, I'm getting the number of ways that I could get a red on the first draw. In the same way, there are 3 of the blues in there, so there are 3 is the number of ways that I could select a blue on the first. Now, notice in this particular case, we are drawing without replacing. So let's suppose we got a red on the first. One of those reds are gone, and we've got 2 red and 3 blue left. So the number of ways of getting a red on the second, if you got a red on the first, is 2. But if you got a red on the first, all of the blue balls remain in there, and there are 3 ways of getting a blue on the second. On the other hand, we might have drawn a blue on the first draw. If we did, one of these blues would be gone, and there would be only 2 ways of getting a blue on the second, while there would be 3 ways of getting a red on the second. And now we're ready to answer the question: in how many ways could we select 2 reds? There are 3 ways to select the first ball. There are 2 ways to select the second. So we have 3 times 2. It would appear that there are 6 ways to select the balls. Now, I should mention here something that is implicit, but it should be spelled out carefully. We're actually counting the order here. So it matters, for instance, if you got a blue followed by a red, that would be different from getting a red followed by a blue. Also, it is just possible that on our red balls, maybe they could be labeled with A, B, and C. We're actually counting, we're paying attention to which ball comes out and then which ball comes out second. So if we got, say, A and B red ball, that would be different from the B and the A red ball. So there are 6 ways of getting a red followed by a red. There are 3 times 3, 9 ways of getting a red followed by a blue. There are 3 times 3, 9 ways of getting a blue followed by a red. And there are 3 times 2, 6 ways of getting a blue followed by a blue. All right, so let's answer the question now. In how many ways could we select 2 reds? The answer is a red followed by a red. There are 6 ways if we're counting order. In how many ways can we select one of each color? Well, one of each color would mean that we take one of these 2 paths, a red followed by a blue. So one of each color is the same as 1 red and 1 blue. There are 3 times 3 ways of getting a red followed by a blue, 9, plus 3 times 3 ways of getting a blue followed by a red. There's another 9. So 18 ways of getting a 1 red and 1 blue if the order counts. If the order doesn't count, then of course these are all just twice as big as they should be. Suppose these are labeled A, B, C, D, E, F, and 2 reds, I might have A, C. That would be different from C, A. If I don't want to count the order, I divide that by 2 because A, C, and C, A get counted as 2, and they shouldn't have. Similarly here, 18 ways if order counts, 9 ways if order doesn't count. The other another possibility, could have 2 reds, you could have a red and a blue. Of course, you could have 2 blues. And 2 blues, just like the 2 reds, there are 3 ways of getting a blue, followed by 2 more ways of getting the second blue. So there are 6 ways of doing that. And the tree diagram, the way that's set up, is that order is counting here. Okay, now we could also answer questions about probability. And if we want to switch these to probability, what we need to do is to turn every one of these into a fraction. And we could answer questions like this. Well, what's the probability of getting a red on the first draw? The answer is 3 out of the 6, because we start with 6 balls, 3 are red, 3 are blue. So this would be 3, 6. Once again, we look at all the lines emanating from a single node. The sum of the probabilities, 3, 6 plus 3, 6 is 6, 6 or 1. That should be the case. Now, if we get a red out the first time, there's only going to be, that one's going to be gone, so there's only going to be 5 left. So this probability is 2/5, this probability is 3/5, and sure enough, 2/5 plus 3/5 is 5/5 or 1, and something similar happens here. The only difference is that the ball that's missing down here is blue, whereas the one that's missing up here is red. Okay, so what's the probability of 2 reds? Well, it would be this, 3, 6 times 2/5. Probability of 2 reds. And you could just multiply this out. You get 6 over 30, and then reduce that. You might just notice that 3 times 2 is 6, which cancels the 6 down here and leaves 1/5. Whether you, no matter how you do it, you get 1/5 for the probability. The probability of 2 reds is 1/5. Since there are equal numbers of red and blue balls in here to start with, of course the probability of 2 blues would also be 1/5.